Right, this first question is quite tricky. Ratio always scares me, so I've had to think about it quite carefully. And this was how I did it. So we're looking at our two bags, and I've decided to go down a ratio route because I read this. So bag A has got 5x and B 3x. So they're not equal to each other, but they are in a ratio. So I take 8 from B and I give it to A. So again, they're not equal, but they are in a ratio. And you're told the ratio of A to B is 11 to 5. So there's obviously more in bag A than there is in bag B, and we can see that quite clearly because of what's going on here. So my next approach is, and I think it's quite difficult to explain, but if this is in a ratio of 5 to 11, if I multiply this bit by 5 and this bit by 11, then they must be equal. Because if I multiply that by 5, I've got 55. If I multiply that by 11, I'd also get 55, which means they're now equal. So I do that to these parts. So I times this bit by 5, and this bit by 11. Okay, and they must now be equal. The rest now is just about solving equations and is reasonably straightforward. Okay, so we're just going to solve this now the way we normally solve equations, working on both sides. So let's take 25x from both sides. And this negative 88, take away 88, so let's do the opposite. So let's add 88 to both sides. And let's divide through by 8. And 128 divided by 8 is 16. Okay, so x is 16. And you start off with 5x and 3x. In other words, you started off with 8x. So 8x is equal to 8 times 16. Whatever that is, 128, I think. And that is your answer. Very fiddly. Okay, so I've done this question already. It's about volumes of cones. You have to remember this formula, I think. Oh, actually, you might be given it. Oh, I'm not sure. I remember it. Remember it anyway. It's not that difficult. So it is 1/3 pi r squared. So there's your circle. Think of that circular base. So it's 1/3 of that times by the height. If I can remember it, you can. So you told the volume. That's going to stay. That's staying. The radius is 4. So you're going to square it times by h. Now this is just about making h the subject of the formula or solving equations. And the way I did that was, this is a divide by 3. So up here it's a times by 3. And then this is already 16 pi. And here it's times by, so on the other side it'll be a divide by. And there you go. Nice question. Alright, a bit of a weird question. How on earth do we start? I really want to know what's the smallest and the biggest amount of money involved in this question. Right, here we go. The person who earns the most is 60,000. So that's the biggest number I'm going to have to use. So I'm going to pop that at the end. And I know the range is 50,000. So if the biggest is 60, big takes small gives you the range. So this must be 10,000. Okay, so now I'm just going to pause it and do a bit more thinking. So I'll pop my scale on. And I'm looking at this bit here. I want my lower quartile. So lower quartile is your first quarter of data, or 25%. And that's that bit here. They earn under 27,000. So if that's 20 and that's 30, 27 is about here. It's quite difficult to do. So this is the start of your box. And in fact, I can put this line in as well, because this is the lowest amount of money. So this is the tell. And so I've got the 27,000, that's the lowest. 50% of the employees earn over 35,000. So this is the median. Yeah, median is your middle, or your sort of halfway along. So I'll go to 35 now, so that's here. So that's the median, that's the middle of your box. And the interquartile range is 10,000. So that's the difference between the lower quartile and the upper quartile. Now this is 27, so now I need to go to 37. Good God, this is incredibly difficult. Obviously I would be using a nice sharp pencil and ruler. Okay, and that now completes the box, and we knew that the highest paid earner was there. Okay, so this is called a box plot. Sometimes some people call it a box and whisker, because there's your box and these are your whiskers. So the important bits are this is your sort of bottom quarter of the data, first 25%. This is your second quarter, the next 25%. This is your third quarter, the next 25%. This is your last quarter. And the interquartile range is how big is the box. Yeah, so from here to here. And this little fella here is the median. Now these questions you're only ever interested in really is the median and the interquartile range. It will come up. So this is a cyclic quadrilateral. So you've got a quadrilateral and the vertices, the corners, are sat on the circle, sat on the circumference. And that's what makes it a cyclic quadrilateral. And you're supposed to know that opposite angles make 180. So to find y, you're going to do 180 minus 33. And to find x, you're going to do 180 minus 68. So what is that? Take off 30, it's 150, is that 147? And then this one is, what's that, 112, is it? Okay. I would be looking at my answers now and checking, does it fit about right? Now, these are very rough diagrams because I'm not convinced that's 33 at all. But, give or take. So, yeah, does that look bigger than 100? Yeah, 147, ish. So always check by looking back to your diagram to make sure you've done it right. And now, lovely question, because we're looking at areas, we're looking at surds, and we love surds. Was it Tia asking about surds the other week? So this question's for you, Tia. So to find the area, it's this side times this side. So we got 10 root 3 times by 5 root 3. 10 times 5. Now a root 3 times a root 3, well, different ways of thinking about it. You either know that the roots will basically cancel each other out, so leave you with 3. Or you might think of it as it's the root of 3 times 3. In other words, the root of 9. And if I root 9, I get 3. Which means my final answer is that centimetres squared. That's your lot.